manufacturing and as well the manufacturing aspect. Then start from chapter 3 onwards until at the end of the chapter, it will be all in the process. So I'm going to talk the first process, which is about the casting. Casting in bahasa Malaysia is tuangan. Alright, proses tuangan. So in the outline of this, I'm going to use the PDF file. I'm going to talk about what is a casting, maybe some information about the history of casting, sejarah tuangan ni bila diguna pakai, what is the advantage and disadvantages of casting, and what are the products can be made through this process, which is a casting, okay, and how we classify casting. And I will explain a little bit on the foundries. Foundries ni is the place where the casting be conducted, okay, dijalankan di mana, macam mana keadaan dia, production dia macam mana, okay. Okay, this is the classification of the manufacturing process. I did explain in the earlier lecture. I'm not remember, but I think in the first chapter. Okay, again, just to show that we're going to touch on this casting, okay, the machining. I'm going to talk after casting, maybe I'll start forming and then joining, and then last will be machining, okay. In casting, we can classify into a few groups, okay. I will say two groups, okay. One is a permanent mold, second one is expandable mold. In casting, mold is very important, okay. Acuan ni sangat penting. Without mold, you cannot perform casting, because casting you have to melt those metal. Metal need to be melt, and then you need to pour. Tuangkan ke dalam acuan in the mold. Okay. If you use the permanent mold, they call it it's a permanent mold, but they call it die. Okay. For example, pressure die casting. Okay, pressure die casting is one of the process in the casting where they melt the metal, then they inject the molten metal into the die, to the mold. Okay. Okay, now second is expandable. Expandable, or other words, you can use a temporary mold. Okay. Difference between permanent and expandable or temporary is that the permanent mold, after you pour molten metal inside, okay, the mold, when you want to receive the casting part, you have to open it mold, then you can get it, okay. But different way with the expandable mold. Expandable mold, if you want to receive the casting part, you have to break it, okay, pecahkan mold. Where expandable mold example, where the mold is made from sand, okay, right. And then we have a machining, simple to classify whether it's traditional or modern. If you look at this slide, it did mention about electromachining. Electromachining is under modern machining. The second one is a mechanical machining. Mechanical machining is a traditional way of machining, traditional way of removing the materials. What is a different is that the modern machining, the tools that being used to remove the materials tidak wajib, it's not compulsory, and it's not touching the materials. If you talk about traditional machining, cara lama, the tools, mata alat yang diguna pakai is compulsory to touch the materials to be removed. Okay, right. Now, the third one is forming. In forming, how we classify this process, macam mana kita klasifikasikan, maknanya macam mana kita nak tahu proses, dalam proses tu sub dia. So different process has a different way on how we classify it. So if you look in forming, it depends on the raw materials. Casting, we look into the mold, type of mold. Machining, we look into how the tools that we use to remove the materials. Is it touch or not? And if you look at this forming, it depends on the form of the raw materials. Is it the form of the raw material before the process in form of shape? Atau bentuk kepingan? Is it in bentuk bark? Bark is solid macam tu. Atau in form of powder? So this is how we classify. If let's say you said the raw materials in sheet form, then there are several process in forming where we can use, where normally the earlier form of material is form of sheet. Contohnya sheet metal forming, press stamping is normally in sheet form. Okay, so now some other process in metal forming, they receive raw materials in a bulk form, dalam bentuk solid macam tu. For example, forging, proses menempa. If you talk about raw materials in form of powder, is like powder metallurgy. Dia kategori dia macam tu. Okay, this slide very important, number one slide in this topic. If you doesn't know about this, that's why there is a question asking, giving a sample of product, and they ask student which a suitable process to be used. This is the problem when they doesn't know how to choose the process. This is a very good slide, and it's good explanation from me. It's a tips on how you want to know which product, which form of metals which is suitable with the process that need to be selected. Okay, the last one is in joining, assembly and joining. In assembly and joining, how we classify in this process is that, are you going to use a fusion welding? There is a fusion, there is a solid state, there is an adhesive, there is a mechanical. The principle dalam joining ni, dalam assembly ni, they use a principle. Dia ada prinsip dia. If let's say you want to use a fusion weld, dia punya definisi is that in fusion weld, in bahasa Malaysia we call it teknik lakur. Okay, lakur method, fusion method is a lakur. Lakur is mean where both metal that you want to join, both of them will melting. This is what we call fusion technique. Second technique is solid state. Solid state, even though it's a metal, it look like they are melting. They are not melting, but they form into high plasticity deformation. High plasticity, dia tak kepada is not melting. Okay, is for example friction weld, friction steel welding is not melting. It just at the condition of material is actually at high plasticity deformation. Okay, so now the third one is adhesive bonding. Adhesive is like using gluing. Okay, glue macam gum gasket ke, silicone. So that known as adhesive bonding. The fourth principle is a mechanical fastening. Mechanical fastening, I think all of you are familiar with. Okay, for example, bolt and nut screwing and so on. Okay, right. Okay, now Before I jump to a videos, I'm going to share a video for about 6 minutes, 7 minutes video. So I will explain fundamental about what is a casting. Again, I'm repeat again. Casting involve a molten metal, okay, logam cair, molten metal, which flow by a gravity. Where did this molten metal flow? It will flow inside the mold cavity by mold cavity by gravity. Two ways. By gravity, you pour the molten metal, okay, like you pour the fuel into the gas tank. It's like that. The molten metal will flow by gravity or by force. Okay, by force is mean you use external force. Okay, um, one of the example is a pressure die casting. You use a force to force the molten metal into the die, into the mold. Okay, now then it will solidify. Dia akan mula menyejuk, mengeras. Okay, and it will menyejuk, mengeras, mengikut, following the shape of the mold cavity. That is the fundamental of casting. Okay, casting wajib, compulsory. The form of raw material must be melting, not high plasticity condition. Okay, and the casting words, the casting. Sometimes you say, "Oh, this is a product." No, no. Mostly people will say, if let's say this is a casting part, people will say this is a this is a casting. Okay, dia tak cakap pun apa part number ke apa, dia kata this is a casting part. Okay, that is a common. Okay? And step in casting, simple. First, again, you have to melt the metal, turn it into liquid. Then you pour the liquid of metal into the mold. Okay, then let it freeze, solidify. After it's completely solidified in the mold, then you start going to remove it, the casting part inside the mold by breaking up, or you open the mold, then you remove the casting part. Simple as that. Is it clear? Ini prinsipal dia, fundamental dia. Kena betul-betul faham. Dia melibatkan peleburan logam. Semua. Either you want to use a permanent mold or expandable mold, same. First step, you must melt the materials. Okay, now, this is examples of the foundry. This is what I'm calling foundry. You will see that there is a departments of making mold. Okay, this is the pouring department. This is the ladle where they pour the molten metal into this ladle. Then the ladle will bring the molten metals and pour into the mold. And this is the casting part still in the hot condition. Okay, after they remove it from the mold. And this is the examples of the casting part. Okay, the closed part, which is with you, where I can give an examples, is engine block. Okay, engine block. All right, most of the engine parts will make from this, but it depends. Some of the engine block, when you buy the engine block part, is quite expensive due to the process. They are not using this casting, but they use pressure die casting. Okay, ataupun tuang secara gravity, where the mold is actually made from besi. You can see what is the difference between expandable mold and the permanent mold is that the outer surface. The outer surface is more the surface is more smooth compared with the expandable mold. Simple. You know your motorcycle engine block. If you look at the on the left, on the right, the cover, the casing cover, for gearbox, and as well the magnetic what they call it, the magnetic coil area on the left, on the right side. You will see that the surface is more smoother than the front engine block. Yang depan tu macam kasar kan. Dekat cover tu cantik because the cover is a metal. They made from aluminium. The block is made by from the cast iron. Okay. On the left, on the right, when you can see when the mechanics open it, is very light. Okay, that is from casting, is from aluminium, and is made from different process of casting. The left and the right cover, the gearbox and the magnetic, I don't know what's generator on the left side normally. Okay, that one is made from injection molding. Okay, it's made from injection molding. Same goes with our hard disk. You know, your hard disk previously, uh, I think not this one, but the previous, not the SSD, the previous hard disk, the thick one. If you open it, there is an aluminium part inside. That one also made from a pressure die casting. Okay, I don't have any examples because example casting is very big and heavy. All right. So this is the examples of parts of products that we made many years ago. In the earlier, when people making weapons and coins, they use a casting. Where casting is one of the cheapest process in the world. Okay, to make parts. Okay, to make products. And this is some of the pictures showing that it's true that this method has been used many years ago in the ancient of Egyptian. Okay, this as well, they make casting. Okay, Indian and Middle East, you know, lots of statue. Okay, some of the religions that they make all this from metal. It's not a solid metal, even though it's big, but it's not too heavy. They can still handle it because there are methods in casting where we can make it without fill up all the mold cavity with metal. Okay, we can make it just like a skin. Okay, this method they use in casting, we call it a centrifugal technique. Okay, centrifugal technique, we pour the metal, molten metal inside the mold or die. Then we rotate the die at high rotational frequency, very high RPM. So what happened is that after a few seconds, then they pour again. They remove back all the molten metal which is not solidified. So they use, I think, about below than just a few percent, 1 to 5% or maybe 2%, where only a few millimeters thickness of metal will solidify close to the wall of the die or the mold. So then they remove it, so you get the shape of like army. You know, last time in London they have that. Some other countries as well, Malaysia as well. Apa nama syarikat tu last time in Setapak, Selangor Pewter. You know how they use a lot of casting technique. Okay. Okay, this as well from China, how they use casting, this as well, bronze. So what we can see from this technique is that the capabilities and advantage of casting is good. Okay. Why? Casting, it can produce a very complex geometry of parts. Simple engine, engine, the block of engine, there are many of holes which is not easy to make by using other process. We can make by other process, but it will take a longer time and it will cost us very expensive. But by using casting, it's only one shot. Okay, at one time, you just pour the molten metal, then after you break up the mold, you can get it, the engine block. Okay. Second thing is that, okay, the same thing, they can create external, internal shape, it's like engine block. And casting as well is a process where they can produce a net. Okay. And other thing is can produce very large, so what is request for? Okay. Can produce a very large part. It's like, I think I did mention about a propeller, a ship propeller very huge. It's about berapa, 2-3 tingkat bangunan. But even the engine of the ship is like a big building. So that as well makes from casting. And the last one is the methods, which is in casting is method where suit for the mass production. When we talk about mass production, is a high volume, okay, jumlah yang sangat besar untuk dihasilkan, okay. And what a disadvantage in casting is that the limitation, they are the limit on the mechanical properties. Why? As we know, we melt materials into a liquid form, then we pour into the die or mold. It's not similar with a metal forming like forge. Okay, that's why casting process after solidify, when we in some other application, we must be aware that the casting cannot stand for vibration. Okay, dia tak boleh stand for vibration ataupun impact, high impact. Okay, high impact vibration dia tak boleh tahan sangat. Dia akan crack, dia akan ada masalah-masalah due to the mechanical property, the limitation of the mechanical properties. And the second is poor in terms of dimensional accuracy, surface roughness for some of the casting technique like sand casting. Some other technique is good, but very limited on. If you talk about which one is better in terms of surface roughness, people will say when you use a permanent mold. But when you use this permanent mold, uh, there is the limitation where you can't produce a complex shape. Okay, internal, external is limited. Okay, but you will get a good surface roughness. But if you use the expandable mold, acuan sementara ni, dia punya surface roughness tak berapa cantik, but it can produce a complex and as well the internal external requirement, okay, of the part. The last one is safety hazards, because all these workers, all the work operators, they are close to the molten metals, which is dangerous, and the fume, you know, these aluminiums, when you melt into a certain temperature, the fume is hazardous ataupun beracun, bahaya, and environmental problem. Okay. Okay, this is a parts can be made by casting. We can see there is a big parts like engine blocks, machine frame. Machine frame ni tahu tak frame? Frame ni. Machine, macam machine apa-apa kamu tengok mesin besar-besar dia punya frame. Contohnya kalau nak kecil, banyaklah part-part for the memasak kitchen yang banyak yang guna dekat production apa, dia punya frame machine tu diperbuat daripada casting. Close to you, especially kakak-kakak ni suka buat kek kan, you all suka buat kek, mixer. You know mixer, tahu tak mixer? Tanya orang lelaki, diorang tahu makan aja. Kena tanya orang perempuan. Mana orang perempuan ni kat sini? Oh, orang lelaki ada yang tahu. Bagus. Okay. So then you know, mixer, dia punya mainframe tau. Dia punya mainframe. Kesemua mainframe, instead of motors ke apa, bukan. Mainframe tapak dia tu is made from casting. Now you know. It's made from casting. And then small parts like jewelries, dentals, banyak. It did mention about small statue, some of the frying pan. It's made from casting as well. Brooch kan, orang perempuan kan punya apa ni, you all punya brooch, some of the watch, okay, is made from casting. That's why they can sell it very cheap, very cheap. Okay, but not all. Sometimes they say casting, but most of the watch casing they make from powder metallurgy. Powder metallurgy. That one is a high volume technique as well and very high accuracy. Jam tu, you beli jam yang murah-murah kan, is I think the casing is made from steel. You beli tu, you ambil hammer, you ketuk dia punya casing. Janganlah cakap doktor ni susah bazir lah beli. Tak, maksud saya kalau nak belajar lah, share lah, beli murah-murah RM10 yang just RM10 ke RM5 atau RM2, RM3 yang besi tu, you ambil, you ketuk, when you hammering, it will break, patah ke apa. Lepas tu you tengok dia punya microstructure, dia punya structure dekat breaking area tu, you will see it's like powder, halus-halus macam tu kan. That is from powder metallurgy technique. Powder metallurgy technique. Okay. And all varieties metal can be cast, is good. Semua boleh, ferrous, non-ferrous, tak ada masalah. Okay. Okay, this is some of the major cast metal and alloys. Type of them, ada grey iron, many aluminum alloy, copper, but 54% grey iron being used to make like engine blocks, some of the housing and so on, because their character dia good in heat resistant, damping, low cost as well, high fluidity. In casting, fluidity is very important because we pour this molten metal, so we have to make sure that the materials flow smoothly through the sprue, the getting area, and then go into the mold cavity. If not, then will be a problem. There will be a defect. Okay, antara some of the defects where it's not completed. When you pour, you think that it's already filled up in the cavity. Once you remove it, then you will see there is a defect. Okay, defect yang mana dia tidak memenuhi semua ruang, especially in the cavity area. Okay. Okay, major application of casting in transport, lots of heavy equipment, in farming, mining, all the trucks, lorries, all these big machine. 1 minute. Right, sorry guys. All right, then we have in machine tools as well, to make machine for casting, the machine for molding, in plant machinery, chemical, petrol, most of the part, all you can see, all this metal, big giant size, is all made from casting. It must be solid. Okay, not in sheet metal. Sheet metal is only metal forming. If you find it is a sheet metal, that is a forming, metal forming. It's not casting. Casting is must be bulk. Okay, so tebal lah. Okay, defense in artillery, all this apa ni, military, most of them are casting. Okay, electrical machine, generator, pump, the compressor itself, and then the pipes. Some of the pipes yang diguna pakai is made from casting. Maybe I will try to share later on videos or whatever, kalau ada masa lah. Kitchen appliance, gardening parts, most of the like sculpture, either furniture, some of it, lampstand as well. Bukan dia punya batang tu, dia punya tapak dia punya foundation dia tu. That one is normally made by casting. That's why is is slightly heavy. This one, the rumah saya ada. Oh, very heavy. Okay. Nampak ni? Ini lampu. Allah, tak nampak lah. Okay. Okay, this is lampu. And batang ni bukan casting. Ni casting. Nampak ni? Heavy. Okay. This is made from casting. Okay, made from casting. Yeah, it's made from casting. That's why they can get high profit by selling this kind of product. It's look nice, but people doesn't know some of the part is made from casting. Okay. Okay. Right. And this is one of the examples of it's a 16 cylinder of motors. It's a block which is made from chromium copper alloy for GJL 300 in the blasting machine. This is in the blasting machine because after sand casting, you need to use abrasive blasting to remove some of the particles because sand, you pour a molten metal after it solidifies, some of the sand who close to the surface of the solidifying process, it will stick at the surface of the casting part. So you have to use a blasting. With the blasting technique, he has a abrasive powder to give high pressure to remove the sand which is stick on top of the surface of the casting part. Okay, you can see this is very big. This is the operator. This is the Audi A6, A4, A8, as well Passat engine. This is Audi 2.5 liter TDI. You can see that this is the engine block after casting, and there are a chocolate color, I would say brown color, and silver color. You can see that this silver color is the area, the surface that been machined by using machining. Okay, so you can see that from the all of the part of casting, only a few percent will have secondary process, which is machining. Okay, due to some of the requirements. And this is the aluminium investment casting part that been used in the cockpit for Boeing instrument panel. Okay, due to the lightweight. Other part casting, we can see that this is this one. I think this is the engine casing untuk gearbox. Okay, kotak gear. Okay, this is a top cover of the engine, bagian atas. But most of the advanced car nowadays, they are not using this casting or metal. They use a high performance plastic. Kebanyakan dah tak pakai ni dah. You tengok kereta macam kereta saya, I think since BMW, Peugeot, Citroen, most of the kereta-kereta Europe, they are not using casting anymore. Dia dah banyak pakai ni. Banyaklah kereta-kereta sekarang pun semua dah pakai high performance plastic. Oops, sorry. And this is another examples where it's made from casting. You can see that this is the brake disc, and as well as some of the joining parts would be used in some other area in the engine. This is the, I think, I don't know what to say, but in the gearbox, okay, where this is, I think this is inside the gearbox. Okay, and this is the compressor on the air generator area. Yeah, compressor, they are the piston, and then you can see they use a motorized or in use the engine, and inside this there is a piston where they compress air into the compressor tank, into the air tank. Okay, and this is as well in the gearbox side. It's made from aluminium, and this, if you can see the shape like this is made from pressure die casting. Okay. This is from the sand casting. This is yeah, gravity. This is pressure die. Okay, we can know pressure die because of the surface. Okay. This is a very huge of I will say it's a shaft where it's made from casting. Okay, been applied in some of the application. I think for maybe for the engine, I think so, or for material handlings, heavy machinery. This is one of the casting as well. This is quite close to us. Stove yang digunakan untuk memasak. Okay, and this is what examples of the frames of the machine where it's made from casting. And the frame ni made daripada casting. Okay, and this is some other parts, automotive parts. This is blocks engine for V6, and this is aluminum alloys for wheels. Okay, this one is a steering wheel. Not steering wheel. Uh, Not steering rods, but the steering wheel casing. So biasanya dia punya steering rod was at the end of this, and dekat sini ni adalah where the rods is directly from your steering. Okay, this one left and right is actually goes to the tire, to the wheel. Sorry. And this is some other parts also being produced for the mining companies, which is made from casting as well. And this is some of the equipments for manufacturing and assembly works that been produced by casting as well. Banyak ini semua pada casting. What different methods lah in casting, there are many. You can see this is the crankshaft. We have camshaft, crankshaft. This is a coupling area. Ini bagian to handle a wheel, lower arm. We have this piston, cams for the motorcycle, small parts. Okay, this is the I would say is intakes and also outlet manifold in front of the engine block and as well at the back of the engine block untuk kemasukan angin dan juga untuk keluarkan asap. And this is a gearbox casing. This is at the area of, I'm not going to say all of them are casting, but some of them is actually from metal forming. That's why gearbox area is quite heavy. I think this one, most of the part is made from metal forming. This is part is not made from casting. This one, yes. Okay, this is alloy rings, alloy wheels for motorcycles. You will see most of you, I just want to share some knowledge, is that especially all those boys, you have all your own motorcycle. Janganlah terpengaruh sangat to buy all these cheap alloy wheels. Cheap alloy wheels, they use a low grades of steel and it makes your motorcycle berat, and the fuel consumption will be very high. That's why your motorcycle cannot go for high speed. If you want to make sure that your motorcycle can go high pickup, a good speed at low and high speed easily, just pull some throttles, a few percent of throttle, it goes. Okay, I suggest I give you some tips that try to get these good alloy wheels. Good alloy wheels you need to spend a few thousand. Yang mana dia sangat-sangat ringan. Okay, and you need to have a good tires. Tires yang murah-murah ni berat. Dia tak boleh tahan. Certain temperature tak boleh. Laju tak boleh. So you need to use a Michelin, which is a high performance tire. It's expensive. Good alloy wheels, even though the size is big, but it's good for cornering, but it's very light. Compare with users cheap tires and cheap alloy wheels, is make your motorcycle berat. Rantai yang baik, lebih ringan, lebih tahan. Okay, even the sprocket. Ni saya ajar macam mana. Enjin biasa je, tapi you lightkan berat ni. Dan in automotive, if you do research, then you know, dalam automotive ni, dalam kenderaan, a few percent of fuel consumption and lack of reducing the performance of the vehicles is due to the weight. So, kena kurangkan berat. Jadi, kalau orang kata doktor macam ni, it mean the rider itself is play the rules. Makna mainkan peranan lah. Iyalah, betul lah. So kalau dah rider macam saya, weight about 100 kilos, it's useless lah. You nak pakai motor Y Super ke Y16 nak buat laju pun tak guna. So bagi orang rider yang memang kurus, berat dalam 60, is enough. You tak payah pun nak buat engine. You just playing with the sprocket, a good rantai, good wheels dan sebagainya. Motor yang torque biasa pun, biasa boleh pergi maybe about 140 easily compare with badan yang berat. Badan yang berat tak boleh buat apa lah, fully modification lah. You have to change all the blocks and so on lah. Benda-benda macam tu. Tapi janganlah modify benda pelik-pelik yang membahayakan diri. Dalam saya ajar, dalam tu saya bagi sikit knowledge pasal benda-benda ni. Okay, this is some other parts as well. Kasih banyak gambar ni pasal casting ni. Okay, this is to show where jenis materials. This is a crankshaft. This is a differential casting. Okay, this is strut wheel hub. Banyak. You can see all this. Banyak sangat pula contoh dia. Okay, and against how we classify casting is first is type of mold. Whether is it consumable. Okay, consumable not to say. Kadang confuse lah, banyak sangat lah. Consumable, expendable, and temporary. Normally people will guna expendable mold. Sama je, consumable, expendable, temporary. We have to destroy the mold every single each casting process. Nak dapatkan casting part, you have to destroy it. Okay. Second is permanent. We can use the mold. Look at the pattern. Okay, by pattern. Pattern ni mungkin now you tak apa nampak, but after this you understand. Pattern ni, there is two type. One is consume, that is permanent. Consume ni maknanya pattern ni, it can be used again and again. We make the pattern been used in expendable mold. Nak buat acuan mold from sand, you must have pattern. Pattern represent for the parts that you want to make. So you nak buat cavity dia, nak buat lubang, you kena ada pattern dulu. And then you take all those sand, okay, padatkan dia, and then you open it, you remove the pattern, for example. Then you close it back, then you start pour the molten metal inside the cavity. That's why pattern have to consume and permanent. And then type of core. Core as well, there is a consume, there is a permanent. Core ni dalam bahasa Malaysia, we call it truss. Why we use core? Core to be used to make a hole of the casting part. Casting part yang ada lubang-lubang like engine block, how they make those holes? If not, all the molten metal will fill up all the cavity area. So we use a core. Then the molten metal will not fill up at the area of the core. Core ni truss, where the core is made of is a consumable and as well as a permanent. For example, consumable is made from sand. Permanent is made from metal. Permanent metal can be reused again and again. But if the core is consumable, made from sand, if we want to remove the casting, we have to break up the consumable core. And the last one is type of filling. Filling type as well, we can classify the casting type. For example, is it we use a gravity, by pressure, or by vacuum? So, for example, if you talk about gravity, is common in sand casting, okay, and as well in a permanent mold type, which is known as uh, a gravity die casting. Okay, 1 minute. I need to drink. Okay. Oh, sorry. Okay. Before we continue, I want to show you a videos about casting. So please enjoy this video. It will take about. Nampak tak video ni? Can you see the video now? Not yet play, but you can see the. Okay, this video is about how they makes. I'm going to share you later. There is a video about bio to show how the casting been used to make this a V6 engine. Okay, now if you look this one, okay, this is a core. Okay, nanti saya akan tunjuk. Okay, this 6 minute, enjoy. It's like we having a break. You can have your breakfast as well for this 6-7 minutes by watching this video to make you more understand whatever that I explained just now. Okay. I don't know whether you can hear the if you can't hear the voice, please use this. Then I try to. Oh wait, before. Oh okay, I'll try. Mana nak play this? Yeah. Okay, can you hear the voice? Boleh dengar suara? Boleh dengar suara? Kalau dengar suara, bagi tam.
Tak dengar betul.
Aduh, tak dengar. Okay, 1 minute. I stop sharing. Saya nak tengok apa. Okay. Saya tak to share audio, share a tab instead. Ni ke? Oh, ada Opera tab. Nanti saya cuba tengok boleh tak? Okay. Now, tengok. Nampak tak video? Can you see the video now? Okay. Now, kalau dengar suara, buat macam ni. Okay, wait. Dengar suara. Okay. Is it clear? Did you watch the videos? Dengar suara saya tak? Okay. Alright. I'm going to show you another video. Yang mana for this video, previous video is like a new modern techniques making this V6 engine. I'm going to share you with in other foundry how they makes these engine blocks as well. Not engine block by technique. Wait, I'm going to find a good one where you can see how these they use this okay. This is about 10 minutes video how they make the centrifugal pump bodies. Centrifugal pump body where they make at I don't know which country. I'm going to share with you. Okay. The first video is modern ways of how they use advanced technique using a good material handlings like robots, ABB type. But this one I'm going to show you like in somewhere else, which is more traditional ways of handling all those things in casting as well. Okay. Okay, can you see the video right now? Can you see the video right now? Not yet play, but please someone respond. Okay, I'm going to play it now. So watch this video. Guys, this is a sand casting technique in producing a centrifugal pump. Right. Okay, guys, wake up. Siapa yang dah tertidur lah, 10 minutes. So, these two videos that I share with you, it shows a different ways of how those manufacturer producing their product by casting, right? I would say the first one is to make those V6 engine, they use a same classification, which is they use the expandable mold. The first one, what you can see is that they make those what we call it a truss, a core, the V6, and the other one completely from start they use a sand casting to make their centrifugal pump, or what we can see is like a similar way of how they make those turbo casing. Okay, turbo kan, tahu turbo? Sama je. So in the center, you can see that they remove that part, center part, that is a core, truss. Yang mana the core is a consumable core. Okay, yang mana they have to pecahkan dia. Alright, so now, again, as I mentioned, there are two categories of casting, which is expandable mold process, where they use expandable mold. Expandable mold is mean the mold will be destroyed when we want to remove the casting part. Okay, okay, and the materials to make those mold is, for example, it made from sand, and the names of the casting is a sand casting, and then plaster technique, and some other materials where they use as a plus binder. Plus binder ni maknanya they mix with the main materials to make it dia akan bind together after a certain process. Dia bukan dia campur tu lepas tu it can keras terus tak, dia sometimes it puts into oven certain heat to make sure that the binder silicates or whatever can, apa orang kata, melekat bersama lah, cair, jadi kuat mold. And then permanent mold is actually made from ceramic refractory materials, or some of them use a metal. Okay. This is a type of casting process to certain classification. For example, in the permanent mold, we have continuous casting techniques, gravity die casting, squeeze casting. We're going to look into every single of these, not all of them, but the continuous casting, gravity die casting, squeeze casting, centrifugal casting. Centrifugal casting normally being pecah, they divide into three: injection molding, compression molding, and also rotational molding. Okay. And then rotational molding is like you want to make those parts and so on. Permanent and then permanent pattern used in the sand casting and shell molding technique. And then we have expandable mold ataupun in expandable pattern, maknanya menggunakan yang temporary punya. We use as in investment casting, ceramics, ceramic plaster. Ceramic plaster is like brother and sister. Why normally they are in the one group? Because the other one can stand for high temperature, another one cannot stand high temperature. Simple as that. Okay, that's why they normally group ceramic and plaster. They have very good the advantage of this ceramic and plaster. You're going to get you can get a fine surface roughness. Okay, the only thing is that the temperature cannot too high. Even though I think ceramics can be high but not too high. So high temperature will go to other process. And we have this like a full mold evaporative pattern casting. Yang sini, I believe you might be confused because there are so many terms. A full mold is mean that the mold itself, the pattern is a consumed pattern. Consumed pattern is mean, for example, techniques of evaporative pattern casting. Sometimes they call it lost foam technique. Why? The pattern is made from foam. You know foam? Foam, kalau you beli barang-barang elektronik yang besar-besar ni, beli printer, dia ada satu putih dalam kan, dalam kotak tu. Itu foam lah. So the same technique, they use that foam. They produce that foam to make a shape of pattern, then they put into the mold, and they won't remove that foam. Because that foam, after you pour the molten metal at hot temperature, the foam will be evaporate, hilang. Okay, dia akan hilang. So that's why they call it full mold, evaporative pattern casting. Some of the terms that been used in 2 or 3 names. Okay, 2 or 3 names sometimes. Okay, like evaporative pattern casting, evaporative pattern casting one, and then they call it lost foam techniques. Like other casting, investment casting, but some other term they use lost wax techniques because they use wax. Dia gunakan wax sebagai pattern, but before they pour the wax, they will put into oven, they meltkan wax too. So wax will be melting, so you will get the mold cavity. Okay, okay, like investment casting, the first one. Sometimes they call it lost wax technique. Okay. Okay, this is the showing the where those under the consumable mold, permanent mold. Okay, under consumable mold, we have two. One is by using a permanent pattern and expandable pattern or consumed pattern. For permanent pattern, you will see that a few casting method will use the permanent pattern, like a green sand casting, shell molding, silicate bond, vacuum casting. For expandable pattern, wax investment casting. This is a lost wax technique. And then, okay, you see, there is a lost foam. Okay, lost foam technique. EPS is stand for evaporative pattern sand casting. And for permanent mold, either they use a die or centrifugal casting. Centrifugal cast, we have three types, which is true centrifugal, semi, and as well centrifuging. For die casting, we have gravity die casting, we have low pressure die casting, and as well high pressure die casting. For high pressure die casting, there are two types, which is for hot chamber and cold chamber. Hot chamber and cold chamber is different, is the way how they pour the molten metal into the chamber before they push the they give a pressure for all the molten metal go into the cavity mold. Okay, that is the only difference. Okay, there is question about this. What is the difference between hot chamber and cold chamber? You have to show the difference. And for special process in casting, like squeeze and as well the continuous casting. Continuous casting is mostly being used in earlier of casting. For example, they want to produce the raw first step of material, like they call it a boom boom papa or whatever it is, where before the material being used in metal forming. Okay, you know, from the scrap yard, you throw out all the scrap metals, so they will bring to one company to melt. Okay, daripada dia punya tu, the molten metal will go down straight away to the mold, and it will shape like square 50 times 50, length about 2.1. It's a bloom or whatever. There is a name for that. And then slab or whatever. And then they, after it cooling down, they will go into rolling mills to the oven, heated up to 1600 degrees, and then go to rolling mills, penggilikan, for less than 1 minute. Then they will produce about 6 mm bar to use for the concrete, for the construction. Okay, that is the continuous casting from the earlier until they come out with the slab shape and so on. Squeeze casting is very special. Squeeze casting. And advantage and disadvantage, which is more intricate geometries are possible if you want to use the expandable mold. And part shape, especially in permanent mold process, are limited, and due to that you need to open the mold. And the permanent mold is basically is economic in terms of high production. If you produce less, it's not practical. Okay, it must be at high numbers of casting part being produced. Okay, this is the foundry pattern shop. I think you watched the video previously, you will see that is a pattern, what they make. Or shop, the shop where they produce truss. Okay, and this is the shop for molding. After they get all the truss, the core, the mold, and then they put it together to be one set of mold. Then this is the melting area. Okay, they pour the melting. This is not the melting production. This is the melting area, melting of the temperature. They put into the ladder. Then the ladder will bring the liquid metals to the pouring area. This is pouring area. What you can see, this is the ladder. Ladder been taken up to the molten area. All the molten metal at certain capacity. Then you put in the ladder. Ladder will pour into the mold. Okay, this is molding. You see, this is a ladder. This is the operator. Okay, pour the molten metal inside the mold. This is all the mold. It's finished? Oh, okay. So today I'm deliver for the first slide in this chapter. Okay, I'm going to so we are at the end of this class for today. I need to take your attendance. Hope by sharing those video previously, it will help a lot of my students to understand earlier about the casting. Okay, I hope it will help you a lot to understand. Basically, need to understand. Okay, nampak tak page lain ni nak ambil attendance. Okay, section 5. Please slide in. Section 5. Section 5, please slide in. Wait, I check numbers of us. Oh, okay. Okay, section 6. Is there any from section 11 of 12? No? Okay, section 6, slide in. Okay, all right, guys. I was late. I would like to say thank you very much for joining this morning class. Okay, if there are any extra class, I will call for the discussion or revise for the test one. Okay, thank you very much. Have a nice breakfast and have a nice rest for the next for your class. Thank you very much and Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Okay, sama-sama.
Thank you, Doctor.
Okay,
Thank you, Doctor.
okay, sama.
Slide malam semalam
Doktor,
boleh
saya
share
nak
ke?
tanya,
Ya,
GDNT masuk ke untuk test 1?
tak ada. GDNT tak ada.
Okay,
GDNT
bagus.
tak ada. Sama.
Doktor,
Ya,
slide semalam boleh share tak, Doktor? Sebab
slide
slide
semalam.
dalam e-learning lain.
Okay, sekejap. Slide semalam. Semalam ada kelas ke? Semalam extra kelas kan?
Ya, betul.
Extra kelas tak ada ambil attendance.
Apa slide.
Oh, slide. Slide semalam tu tak ada dalam e-learning ya?
Ada lah, Doktor. Section 6 punya e-learning ada.
Ada. Yeah, okay. Sekejap, give me 1 minute. I
you-
try to share. Yeah,
He asked for the test punya slide ke limit punya slide.
kejap. Yang macam mana tak faham saya? Limit macam mana?
Semalam kita punya slide kan the one that talks about tolerancing and limits, right?
Ya.
Tu slide sudah ada kan?
Yang itu tu I tanya, dalam e-learning tak ada ya? Okey, tak apa, nanti I letakkan dalam e-learning.
Oh, ada, Doktor. Saya salah pandang.
Mesti ada dalam e-learning. Just double check. Please double check.
Alright, Doktor. Sorry.
Okay.
Doctor,
Yes, Lau.
one question.
Yeah.
Chapter 1, introduction 5 does not include in test 1
Yes.
The one-
Organization.
Organization
No.
tak ada.
Yeah,
Oh.
tak ada. Yeah. Okay.
So only 4 subtopics in chapter 1 and one more about the tolerancing and
Yes.
limits. Okay.
Ya,
Thank you,
betul.
Doctor.
Betul. Okay, sama.
Thank you, Doktor.
Okay, sama semua.